Howdy, welcome to our Scuttle final project presentation. Our group members are Zoe, Orion, Lewis, and Alan.
For our mission, the mission of this project is to have the Scuttle track different color objects within a predetermined boundary, count them, log their coordinates and color, and then generate the results. The robot will start using human input, which is the boundary, and continue running autonomously until it finishes.
So for the sensing and automation on this project, we're going to be using the LiDAR to track nearby objects. We're going to use the color sensor to differentiate between the color of the objects. We're going to use the ultrasonic sensor to prevent the Scuttle from bumping into obstacles and allow it to move semi-autonomously. We use the L1 motors.py and L1 lidar.py in order to both establish this relationship between where the objects are in the camera and where they are in real life. Use this to allow the robot to move around comfortably. For actuating, there's fairly few actuating portions. We're going to use the motors to move the robot around the location or the boundary that we've established. We're going to use the LiDAR sensor to scan around this area and determine where the objects are and how far away things are from it. So and the range of motion within the box coordinates is given at the start, so the robot will know where it's at and know where it's been based off of the coordinates of the robot and the position of the objects within that coordinate grid.
For data collection, we're going to log what color each item it is, and also the 2D coordinates of the items in Cartesian coordinates. We're also going to give statistics using of the most common color from the data we received, and the data will be stored in an array in the form of the X coordinate, the Y coordinates, and the color hex code. Both the coordinates will be in meters. We expect the number of data values to match the number of objects, and the X and Y coordinate ranges are set by the user, while the color hex code range from 000000 to FFFFFF.
For the mission statement, so it's going to receive a boundary in the form of coordinates. The boundary is also going to be made out of a different colored tape. That way it can sense where the boundary also is. And there's also going to be like a grid kind of made of tape as well. So it knows as a different way to collect data as well. It's going to run around and scan throughout the boundary and detect objects. It's going to do this in a sweeping motion inside this predetermined box. It's going to log the coordinate of the object and the color of the object, and it's going to continue to detect the object until the entire boundary is covered, and it's going to know this by the grid dots, knowing that it's covered this many dots and therefore it's covered the entire boundary. And it's going to give statistics relating to the color of the objects, so it's going to know how many of each color there's going to be and which one had the most.
So for the failure modes, some parts that could fail would be that the robot wouldn't be able to find any of the objects and sense them, so no objects would be found, or they would miss the object, or the location of the objects could be inaccurate from what it senses, or the robot could go outside of the boundary that we put, and the robot would continue on its mission as long as it's able to be within the boundaries. And if it isn't, it'll show that it didn't sense anything or that it sensed it incorrectly, and then we would be able to see that through our data.
So there's a couple additional items that will be used for this project besides just the Scuttle robot and the BeagleBone board. We want to use an Arduino Nano Every to help with data processing from the CV because it's a fairly intensive process and it would be bad to overload the BeagleBone, especially when it's already tasked with movement and making sure it's not hitting anything. The LiDAR sense will be attached to the BeagleBone. That helps with the movement and not hitting anything. The camera is going to be good for data processing and knowing where the objects are, and that'll allow us to detect the color of the objects. And the ultrasonic sensors are, as stated earlier, they're used for ensuring that the robot's not too close to anything or going to hit anything. Yeah.
Thank you.
Thank you very much.
That's our presentation.
Thank you.